Okay. Let's look at the configuration. We open this switch. First, let's look at the VLAN. Show VLAN brief. After coming in, we must still go under the interface. We just deleted the interface. Let's reconfigure. E00 interface. Switch port mode access. Then switch port mode access VLAN 10. Then we enter the E01 interface of the switch. The same. Switch port access VLAN 20. We have now divided the interface. Their configuration is exactly the same as before. Then we know how to enter the VLAN if interface of the switch. Also very simple. Interface VLAN 10. You'll see it here. The sub interface we entered just now is a sub. Now this is an if. This is a VLAN if the interface. After coming in, let's just configure the IP directly. This is VLAN 10. Just configure the gateway of VLAN 10. 192.168.10.254. 255.255.255.0. Then enter VLAN 20. Configure the address directly. 192.168.20.254. No shutdown. Let's now check the IP interface on the device now. You can see it here. 1 VLAN 10. 1 VLAN 20. VLAN 10 is 10.254. VLAN 20 is 20.254. So now the address is matched. Let's just look at the routing table. Show IP route. You will find, although it is a switch, but there is also routing table. We can see a directly connected network segment in the routing table. Is 10.0. This is VLAN 10. This is VLAN 20. So now you will find a data access 20.1 from PC1 to the switch here. It queries the routing table. It will see that PC1 wants to access 20. Then the local outgoing interface is VLAN 20. VLAN 20 is a virtual interface. Specifically why it can go out from the 0/1 interface in the end. Just follow the order I just said. It can eventually learn the interface. That is IP, MAC, and outgoing interface. It can be matched one by one through the local ARP table and MAC address table. Finally, the outbound interface can be found. Send traffic down. Let's do a test. From PC1 we now go to ping 20.1. I can still ping, although this picture has been changed. Device delete to delete. But both of them have been able to communicate. That is, the above device can always help it forward data across network segments and VLANs. This is called mutual access between VLANs. Now many functions are integrated into this one device. And the real interface. Actually, it is an access interface. So actually, for the virtual interface in the device just now. That is, VLAN 10 and VLAN 20. When this data is received, it will be unpacked. When unpacking, it will remove the corresponding tag. When sending data in the future, it will put the 20 tag on it again. This is called repackaging. Then remove the 20 here. Everyone understands the specific concept of VLAN if. Okay. I will now make a summary with you. The purpose of our VLAN division. Not to block their flow. Actually, the main purpose is to make layer 2 unreachable between different VLANs. We just want it to be different on the second floor. Because the overall transmission method of the broadcast is the second layer. Layer 3 does not forward broadcasts. Router interface does not forward broadcasts. So strictly speaking, refers to the failure of the second floor, instead of 3 layers. So we are more inclined to do traffic isolation for the second layer. And the broadcast is actually spread based on the LAN. Router interfaces do not forward broadcasts. Let me give you an example. If the router interface forwards the broadcast, the ARP packet we sent, if the router interface also forwards our billions of internet users around the world, everyone sends broadcast packets every day. That's too exaggerated. Therefore, the router interface must not forward the broadcast. Only devices such as switches forward broadcast traffic. The purpose of our VLAN division is to make the second layer unreachable, instead of 3 layers. What we finally achieved is to allow unicast. But the broadcast is not working. Normally there will still be some traffic exchange visits. Okay. I didn't expect to talk about VLAN for so long. It doesn't matter. We have a little configuration left for next class. Let's briefly introduce STP. In fact, it is biased for other configurations. Not so much to understand. So it's not hard to say. Most people will find STP difficult. But what we have learned at this stage is relatively simple. I will draw a picture first. This is a typical architecture diagram. Let's not talk about what STP is today. Let's first talk about what problem it solves. Let's draw a few devices first. Draw a few devices. This is a standard architecture diagram. These are switches. Assuming egress, this is a firewall. The devices below are all switches. This is the aggregation layer switch. Below is the access layer switch. Then the access layer is connected to the terminal. There are even PCs 1 by 1 below. So what are these devices at the access layer? Assuming this is the equipment in the office on the first floor. Behind this is the equipment in the office on the second floor. This is the equipment in the office on the third floor. Then, if such an environment, this is the operator. We are now going to data access. We are now on each floor. There is an access layer switch. Will be connected to the aggregation layer switch. This structure we talked about before. I won't describe it anymore. So think about what's wrong with this picture. These devices on the first floor are connected to the switch on the access layer on the first floor. The equipment on the second floor is connected to the switch on the second floor. The one on the third floor is connected to the switchboard on the third floor. Yeah. There is a single point of failure problem. The switch in the office on the second floor is connected to the aggregation layer. Only one line. If this thread breaks, we usually don't mean the line either. Usually refers to, for example, there is a problem with its interface or its interface. The interface is actually more prone to damage. But we usually say the line is broken. What we call a broken line. In fact, more refers to the interface has a problem. Once there is a problem with the line, then don't go online on the second floor now. Now connect to the external network with this one line. Generally speaking, the computer room has operation and maintenance. Someone will check regularly. Airtightness is also very strong. Let's talk about a single point of failure. Once this line is broken, the second floor will not be able to access the internet. And someone might have a way. If this thread breaks, just connect the 3 devices below. If it breaks later, the traffic on the second floor is like this. Do you think this is feasible? It won't work. Access layer switches usually have a performance problem. Even terminal. In the future, the lower layer terminal traffic will be aggregated from the upper connection port.